So first one is the voltage gain is stabilized. Stabilized means for a longer range of frequency, my voltage gain is going to be constant. Because the bandwidth is high, right? When the bandwidth is high, the voltage gain will be very constant for a relatively larger run of your frequency. The frequency response will enhanced. Enhanced means the bandwidth is going to be increased. The frequency response will be looking very broad. You know, frequency response means I'll be drawing frequency versus gain, a semilog graph. So if you draw the frequency versus gain graph, you find that it is going to be a stabilized graph because my bandwidth is going to increase. When you apply negative feedback, the input impedance is increased, which is a very good advantage for you and it is a requirement for you. When I'm going to apply the negative feedback, the output impedance will be reduced. So in the input impedance is going to be increased, my output impedance is going to be reduced. And also reduction in noise. You have noise reduction happening. So even by mistake, if some noise is entering your amplifier, if you don't have feedback, that noise will also be amplified. So whatever the signal you get after amplification will have a lot of noise. It will not be very clear. But the same amplifier, if you add feedback, and then if you by mistake noise gets added, that noise will be amplified, but because of the effect of negative feedback, the noise strength will be reduced. Okay, that is a very beautiful property of negative feedback, reduction in noise. So reduction in noise happens when you apply negative feedback to your amplifier. So even if noise enters your circuit accidentally, it will not be amplified by your amplifier. It will be reduced by the negative feedback effect. Increase in linearity. I can say in other words, reduction in distortion. So distortion and linearity are related. You have seen power amplifiers, right? So in power amplifiers, class A amplifier is the only more linear amplifier. So distortion will be very less. Class B, class A, B, class C, linearity is very, very poor. Class C the highly non-linear. Efficiency 100%. Distortion is also very high. So linearity and distortion are related. Remember, linearity and this when the circuit is non-linear, distortion will be automatically introduced. Linear na enna meaning? Ohm's law, we have studied V is proportional to I. That is the example of linearity. Suppose V is proportional to I plus I square. It depends on I. It also depends on I square. That means it is non-linear circuit. So when you apply negative feedback, the circuit will try to become more linear, which means my distortion will be naturally reduced. And all these properties of negative feedback, whatever I have summarized here, we'll be studying, we'll be mathematically deriving parameters and checking how this properties are justified. Just if I say it is not enough, right, I have to mathematically prove that my voltage gain is stabilized, my frequency response is enhanced, my input impedance is very high, my output impedance is very low, my noise reduction is very good, the distortion is reduced effectively. These are the properties we are stating, but we have to substantiate these properties, the proper proofs, right? So that is what we are going to see, how these properties are mathematically proved for negative feedback.